Welcome to you all in my YouTube channel Express Mathematics. In today's video, I am going to explain you about the unit vectors I, J, and K. Before starting, I want you to make sure that you please subscribe my channel right now if you have not already subscribed, so that I will be encouraged to make more videos, and also press bell icon so that you will be informed about my coming videos. So now I am going to explain about the unit vectors I, J, and K. These unit vectors I, J, and K are of great importance in the vectors because these are frequently used while solving problems on vectors. Okay. So for this, let us take two mutually perpendicular straight lines O X and OY. Okay. And let I and J be unit vectors along two mutually perpendicular straight lines OX and OY. Then I and J, vector I and vector J, are defined by vector I will be 1 0 and vector J equals to 0 1. Okay, so here vector I along OX and its length is 1 unit, and vector J is along y-axis and its length is 1 unit. Okay. In the beginning, there is a chances that students may be confused with this IJ and other type of unit vectors. If the length of the unit vector is 1 along this direction, suppose this direction its magnitude is 1, okay, there is the chances that in the beginning student may write for this also I. Okay, that's not I. Okay, for to be I, it must be along this x-axis, unit vector along x-axis, and for to be J, it must be unit vector along y-axis only. Okay, so these I and J, these are fixed. We do not take unit vector in any other directions as I and J. And now unit vectors I, J, and K in three-dimensional space. Let I, J, and K be unit vectors along three mutually perpendicular straight lines OX, OY, and OZ. Then I, vector J, and vector K are defined by vector I equals to, we can add 1 comma 0 comma 0, vector J equals to 0 1 0, and vector K equals to 0 0 1. Like this way we can define. If OX, OY and OZ are mutually perpendicular straight lines. Okay, so here mutually perpendicular straight lines can be visualized in this way. Okay, we can take here this edge as x-axis, this edge as y-axis, and this pen, this is the vertical one, this as z-axis, x-axis, y-axis, z-axis. So one vector I, unit vector along x-axis, this is vector I. Okay, one unit along x-axis, that is vector I. One unit along y-axis, that is vector j, and one unit along z-axis along this pen vertically, that is vector k. Okay, and here if you draw a coordinate axis, then it looks like this: O, x, y, z. These are mutually perpendicular axes. Okay, and along x-axis unit vector is I, along y-axis unit vector is j, and along z-axis unit vector is vector k. In this way, I is 1 0 0, j is 0 1 0, and k is 0 0 1. Okay, along x-axis only x coordinate is 1 and other coordinates will be 0 because its length is 1, so it is 1 written. Along y-axis, except y coordinate, other coordinates are 0. Along z-axis, except z coordinate, other coordinates are 0. Okay. Now the theorem related to this these unit vectors. Theorem. Okay. Every plane vector a1 a2 is of the form a1 I plus a2j, and conversely. And second theorem is every space vector a1 a2 a3 is of the form a1i plus a2j plus a3k, and conversely. Okay, and the proof of this 1 and 2 is similar. So I will show you the proof of anyone. Okay, proof of I, proof of I number. Okay, here a1 a2 a3 equals to, we can write a1 plus 0 plus 0, and this a2 we can write as 0 plus a2 plus 0, a3 we can write 0 plus 0 plus a3. Okay, okay, so here a1 is x coordinate, so remaining y and z coordinate 0 0 we have written. Here a2 is y coordinate, so remaining x coordinate and z coordinate 0 0 we have written, and it is z coordinate, z coordinate, so x and y coordinate 0 0 we have written. In this way we have written this form. Sorry, excuse me. Now we can express in this way: a1 0 0 plus 0 a2 0 plus 0 and 0 a3. Okay, we can write this in this way. Okay, because while adding we again get the same expression: a1 plus 0 this, 0 plus a2 plus 0 this, and 0 plus 0 plus a3 we will get again this much. So instead of this we can write this step. And now from this a1 can be taken out as common, because this is a1, this 0 means 0 times a1 we can suppose, this is also 0 times a1 we can suppose. So a1 will be common, so here will be 1, here will be 0, here will be 0, plus from this a2 can be taken out as common, 0 1 0, from this a3 can be taken out as common, 0 0 1. So according to our definition, 1 0 0 is vector I, a1 vector I, plus a2 according to definition this is vector j, plus according to definition this is vector k, a3 vector k. Okay, in this way a1 a2 a3 equals to, we have written a1i plus a2j plus a3k. Therefore a1 a2 a3 equals to, we have written this one. And conversely this equals to also will express in this form: a1i plus a2j plus a3k. From this also we will get a1 comma a2 comma a3. Okay, this equals to a1 I means it is 1 0 0 plus a2 j means 0 1 0 plus a3 k means 0 0 1. Okay, and now we'll multiply inside here: a1 times 1 a1, a1 times 0 0, a1 times 0 0, plus a2 times 0 0, a2 times 1 a2, a2 times 0 0, plus a3 times 0 0, a3 times 0 0, a3 times 1 a3. Okay, now this a1 plus 0 plus 0, a1 plus 0 plus 0, 0 plus this a2 plus 0, second component is added with second component, this third component also added together, 0 plus this 0 plus this a3. So now here a1 plus 0 plus 0 it is a1, 0 plus a2 plus 0 it is a2, 0 plus 0 plus a3 it is a3. In this way from this also we have got this one. Okay, first of all we had got from this to this. In this way this completes the proof. For a1i plus a2j plus a3k equals to, also we have got this. So this completes the proof. Okay, in this way I have shown the proof of the theorem related to I, j and k. Okay, and next is the collinear vectors. Now the definition of collinear vectors: any number of vectors are said to be collinear if they are parallel to the same line. Okay, any number of vectors are said to be collinear if they are parallel to the same line. And otherwise they are said to be non-collinear. Okay, otherwise they are said to be non-collinear. Okay, if they are parallel to the same line, they are said to be collinear. Otherwise they are said to be non-collinear. Any vector are collinear with a given vector, collinear with a given vector, A can be written as R equals to k times of vector A, where k is a scalar. Okay, so this collinear matters is used in coordinate and as well as in vectors. So in coordinates we say collinear points. Their co means same, linear means a line lying on the same line. Okay, here we say collinear vectors. Okay, so for the points to be collinear in coordinates, they should lie in the same line. But here collinear meaning in vector is synonymous with parallel. Okay, so if vectors are parallel, then they are said to be collinear, because in vector we can take any point as the origin, and if the vector is shifted parallel to the another vector, then they lie in the same line. So parallel vectors are said to be collinear. Okay, and so parallel vectors are also of two kinds. They are like and unlike time. They may be like vectors means they have same direction, unlike vectors they have opposite direction. In both cases they are said to be collinear. Okay, so for to be collinear, suppose one vector A is here, and then another vector is in this place. Okay, this is vector B, and this vector B will be same as another vector B here, having same direction and magnitude same as that of this B. Okay, this can be shifted here because origin of this vector is here and origin is shifted here. So for vector, origin can be taken anywhere. So in this case, this A and B, they lie on the same line. Before this they were parallel, but now they lie on the same line. So the name is the collinear vector. Okay, so if vectors are parallel, they can be fitted in a straight line. So the name is the collinear vector. So in vectors, to say parallel vectors, to say like vectors or unlike vectors, they all are collinear. Okay, in this way we can define collinear vectors. Okay, I hope that you found this video helpful. Thank you for watching. And if you have not already subscribed my channel, please subscribe it right now, so that I will be encouraged to make more videos. And also press bell icon so that you will be informed about my coming videos. Thank you very much.